My name is Jessica Hammersley. I am the president for Eta Kappa Nu, which is an honorary computer and electrical society at WVU. And today we're going to do some work with static electricity. So if you aren't familiar with static electricity, oftentimes you'll be introduced to it with a balloon of some sort. So static electricity, what we're going to use here tonight is there's basically one basic principle that we're going to use, which is that if you use a balloon and you rub it either in your hair, or if you rub it on carpet, or if you have wool socks, that will also work. If you rub it on one of those things, you'll build up a really big negative charge on the surface of the balloon. So that will be kind of like your negative electrical charge that we're going to be using on soda cans and then creating our own electroscope to see what that negative charge does with other objects. So if you guys are ready, so using that principle of static electricity, we'll go ahead and get started. So the first thing that we're going to do is we're going to do a thing called soda can races. Now this one's pretty fun, and if you have a sibling or a parent nearby that you can do this experiment with, you can compete with each other and have a little fun family competition. So what we're going to do is we're going to take a balloon, and each person that's participating in the race is going to need a balloon of some sort. So once you have the balloon, you're going to need that. And where did I put over here? You're going to need a balloon, and you're going to need a soda can of some sort. I've got my little V8 can right here for this. So what you're going to do, it's pretty simple, and you'll get a chance to try it out before we do any races here. What you're going to do is you're going to take the balloon, and you're either going to rub it in your hair, or if you're like me and your hair is currently just a little bit damp and it won't work for this, you can see I have my door open over there. I'm going to rub this on the carpet, and that's how I'm going to get the static buildup from that. So what you can do, I'll go ahead and demo this. So if you take this balloon and you really quick go over on carpet, and you make sure you get a really good charge on it. So if you rub it for a few seconds, that should do. If you look here, so we have this soda can here. Let me see. Should be able to see now. If I take this charge next to the can, it starts to move it. So if you see, the can is slowly starting to move. And it should start to move towards the balloon. So if I get a really good charge on the balloon, all right, I think I've got a pretty good charge. So if you watch, let's see, can you see the soda can moving? So what that's doing is, you can see there was a really good roll right there. So what it's doing is the negative particles on the balloon are attracting the positive particles on the soda can. And so what that attraction does is it makes the soda can want to come towards the balloon. So in this case, we see that opposites attract. That's what this whole thing is saying. So you have those negative particles on the balloon, you have the positive ones on the can, and the two attract and makes the can want to roll towards the balloon. So if you get a really good charge, I've seen people have a good enough charge to get it to roll like 10 or 15 feet before they have to charge it again. So if you use that, then you can do a race with your siblings over who can roll their can the fastest, and stuff like that. Go ahead, we'll move on to the electroscope part. So let me get adjusted up here. Oh no. All right. So to make your own electroscope, you just need a few different supplies. So the first thing that you're going to need a styrofoam cup. This is going to be like the base for your electroscope. So we're going to start with that. We then need another soda can. For this one, it's really important that your soda can has a tab on it. I know some people will remove the tab after they've drunk the soda. So you need to make sure that this one has a tab in order to do this part. And then you'll need some electrical tape. You'll also need some aluminum foil. If you don't feel comfortable with some aluminum foil, you can just tear it off. You can use scissors for that. And then we'll be using scissors to cut the aluminum foil into little tiny pieces. Let me adjust this so you can actually see. All right, so what we're going to do, so we see here we have our styrofoam cup and we have our soda can. So what we're going to do is we're going to put the soda can on horizontally like this. It's really important that you have the tab sideways like this, or that you have it flat like this. Either or will work, but you want to make sure that it's not like diagonal. So once you have that together, you're going to take your electrical tape, if I can find the end. You're going to want to tear off a pretty big piece of electrical tape. So what you're going to want is for the tape to be able to start about here on the cup and wrap around on top of the soda can and get to the same place on the back. So you're going to want a really long piece. You can always put on a second piece if you don't get it long enough, that first piece. But it's going to be a pretty long piece of tape. Regular tape will work if you can get it to stick. The tape is a lot easier to stick to the can, which is why using electrical tape is better. But if you can get it to stick, it will work fine. It'll just take a little bit of patience for it. So when you're putting this tape on, you're going to want to make sure that you keep the tab either horizontal or vertical. Either or is fine. You'll just want to make sure you keep it that way. So you should have something that looks a bit like this. You're going to have your cup and then the soda can taped on like that. And then what you're going to do is you're going to take a piece of aluminum foil. I've already pre-cut mine. And what you're going to want to do is you're going to want to get a few strips that are about, they're going to look like this. You're going to want them to be about 2 inches long and about 1/4 of an inch in width. Now I know that number might be hard to figure out exactly what it should be like if you don't have a ruler on you. So I'll give you a little bit of an easy way to estimate it. So if you take 3 fingers like this, and then you use that to measure out on the aluminum foil, that will get you about 2 inches. It's not exact, but it's pretty close. And then once you have those 3 fingers, just to get the width of it, you're just going to want it to be really thin. I'm trying to think of, if you bend your finger and you look at the middle knuckle, it should be about 1/3 or half of your middle knuckle will get you to 1/4 to 1/2 of an inch. If you don't have a ruler on you. If you have a ruler on you, it'll be easier than that. But no worries if you don't, that will get you a little bit of an estimate. You're going to want to get at least 2 pieces, but it might be good to have 3 or 4 because we're going to have to crumple the edge of this. And I know when I was doing this that I crumpled 1 piece too much. So it might be easier for you to cut a few extra pieces in case you do that. You're going to want to cut 3 to 4 pieces of aluminum foil. You're going to want it to look about like this. So it's going to be 2 inches long by about 1/4 inch in width. And I was saying if you don't have a ruler on you, if you want to get a good estimate, if you take 3 fingers together like this, that will get you about 2 inch in length across there. And then if you're trying to figure out 1/4 inch width, if you fold your middle knuckle on your pointer finger, about 1/2 to 1/3 will get you about 1/4 inch. Or if you have a ruler, you can use that instead as well. So what we want to do with these pieces, if you remember how I had said that we want this tab to be either horizontal or vertical, the reason for that is we're going to want to hang these pieces from that tab. And it's really important for this that we do not tape these pieces. We're just going to bend a little bit of a hook and put it on there. So we're not taping, we're just going to hang it. So what we can do, and I can show you an example a few times, we're going to have this piece, and on the end, we're just going to crumple it a little bit. So it's almost like we have part of it folded up. And then once we have part of that folded up, we're going to want to make a hook with it. And the hook doesn't have to be pretty, just enough that you can hang it from the soda can. So it looks something like this. And then you can see when I hang it here, it should be able to pretty loosely hang. So you should be able to move the soda can a little bit and have it still stay on there. It doesn't have to be like perfect, just like if you were just wiggling it a little bit, it would stay on there. So we're going to want to do that twice. So I'll show you again with the second piece what we're going to do. So again, we take another strip about that same length and width. We're going to want to crumple up one edge, not the whole piece, just part of it. We're going to want to make a bit of a hook. So that looks something like that. You've got the flat piece still with the crumpled up hook. Once you have the hook, you're going to hang it on the tab. It's a little tricky, so if you struggle a bit at first with getting it to hang on there, that's okay. That's why we cut extra pieces, so we can have extra pieces in case we accidentally crumple up one. So you should get something that looks like this, where you have the two pieces hanging off the tab. So what we're going to do, we have officially made our electroscope. Yay! So this can be used to figure out the presence of either positive or negative particles around us. So what we're going to do again, we're going to take our handy dandy balloon. We're going to again get static up on it. So I'm going to go real quick and I'm going to rub this on carpet so I can get good static, and then you should be able to pretty easily see what happens with this. So let me just move out of here real quick. I'll just get some static. Let's see what happens. Look at that. Do you see how it's moving? It wants to go towards the balloon. So again, what we're watching here is exactly what was happening with the can. So you can see there's even some charge still on it. And so this is also helpful to see. So you see that there are two things worth noting here. So the first part is exactly what happened with the can. So when we got static on the balloon, there was that negative charge on the balloon, and it was attracting the positive charge in the soda can, and it was making the soda can want to go towards the balloon. Opposites attract. So the same thing happened here. The balloon had that negative charge on it again, and it attracted the positive charge in these aluminum strips. But if you look now, do you see how the two strips are staying apart now? They didn't fall back together like we saw before. They're staying a little bit apart. So what that is showing is that we've brought out the positive charge in these aluminum foil strips because of the negative charge here. So I was saying that opposites attract. But if something is a light in charge, it's going to repel. So we brought out the positive charge in both of these strips here. So now both of them have this massive positive charge on them. And so they have the same charge now, and they don't want to get back together. And that's why they haven't drifted back together. That's why they're staying apart. We found here opposites attract, similar things deflect, they don't want to be together. So yeah. So those are the two experiments that I had. I know it wasn't the longest one, but I think both of these are pretty fun ones to do. Especially the soda can races. If you and your family can get a good charger on a balloon and can race soda cans, you will have a fun time. I've done it with my family before. We got competitive with it. So you'll have a good fun time if you do it. And then yeah, this electroscope lets you see about the opposite and similar charges with it as well. So yeah. So feel free, both of these are things that you can easily replicate on your own. Feel free to try it out on your own whenever you want, yeah. Yeah, so with the soda can, I think one thing to keep in mind is that you need a pretty good charge on the balloon to get the can moving a lot. So don't get frustrated if the first time or the first two times that you try and get static from your hair or static on the carpet or static from a wool sock, anything like that, if it doesn't move the soda can. That's okay. It might take you a little bit to get a good enough charge on it to get the soda can to move, but you will. I promise you, you will eventually get it. For this one here, this doesn't require anywhere near as much of a charge. So if you are worried that you're like, I don't feel like I'm actually doing this right, you can easily make one of these and test out the balloon charge on it there. This is really cool. If you see now, they've drifted back together, and it's because the positive charge has slowly spread back out through the pieces of aluminum foil. So you can also watch, if you do this on your own, you can watch over time as the pieces of foil will slowly distribute that charge back again. Other things to keep in mind. When you mess with the aluminum foil, like I said, you should cut some extra pieces because it's really easy to crumple it up to the point that you can't use it anymore. Something else you can also try with the pieces of aluminum foil is you can see how thick can you get those pieces and still have the balloon pick them up. So that's an experiment that you can try out on your own as well. Styrofoam is definitely going to give you a better reaction. So if you really want to see if you have a balloon with the aluminum foil, if you really want to see that aluminum foil move a lot, Styrofoam is going to be a better effectively insulator for it. So it's kind of acting as something to kind of act as a neutral ground for the different charges. So you can use plastic, I believe, but if you want a really good reaction, you're going to want to use a Styrofoam cup.